Please help me in welcoming Mr. Robert Poole.
Thanks, Tim, for the introduction, and glad to be here today. I had to catch a plane in Washington, and I was 45 minutes late due to a fuel leak discovered at the last minute before pushback, but I got here in time, and I'm very glad to be here. My subject today, as you can see on the screen, is the future of the interstate highway system, which I have finished a big study that came out in September of this year. The interstate system is our most important, most valuable surface transportation infrastructure. It's with only 2.5% of all the lane miles. It handles 25% of the vehicle miles of travel. And I verified those numbers in the federal highway statistics. It's really amazing. The problem is that the system was designed in the 1940s, started construction in the 1950s, and the basic specification for most of it was 50-year design life, other than the bridges. And a lot of the system is already 50 years old, and over the next 2 decades, all of it will exceed 50 years. Many of the corridors need widening. Many of the designs are obsolete. We have about 200 major interchange bottlenecks around the country, mostly in urban areas, that are huge impediments to truck traffic as well as commuting. So we've really got a need for rethinking and reconstructing and modernizing the system. So the study that we did that came out in September, purpose of it was to estimate what it would cost to reconstruct all the existing lane miles. Number two, to estimate the cost based on quantitative criteria of where are lane additions needed and what would they cost. And third, to assess it as looking at lane additions, look at those corridors where there's so much truck traffic that there's really a case for separate truck-only lanes. And then to figure out how to finance the whole project. And the goal in this case was to see if all electronic toll collection, toll revenues done by all electronic toll collection would provide a feasible funding source for this, because there is really there's no hope in sight for existing fuel taxes being able to do this for a variety of reasons that I don't think we need to go into here. So why consider toll finance today? Some of you who know the history of the interstate system may recall that when the system was being planned, the initial thought was that it would be funded by tolls. Pennsylvania Turnpike had opened its first section in 1940, just before the war, and it was finished after World War II. It was a huge success. Everybody saw this as the superhighway of the future. New York began the New York Thruway, toll road, Massachusetts Turnpike, Connecticut Turnpike, Ohio Turnpike. This was the whole Northeast was doing what became part of the interstate system with toll finance. But when people looked at the other states, particularly in those days, in the 50s, the South and the West, they said, the traffic levels are nowhere near. We don't have the economic activity that would make it viable. So they decided instead on the federal fuel tax and the Highway Trust Fund as a dedicated source of revenue for doing that. Well, it turns out now the South and West are vastly different from what they were in the 1950s. Huge amounts of economic activity. We have a nationwide trucking industry that grew up largely because of the interstate system, which is a mainstay of goods movement in this country. We also have the fact that toll roads are designed for longer, more durable lives, because in toll financing, your objective is not to minimize the first cost, it's to minimize the life cycle cost. Toll roads are run much more like a business than ordinary highways are. So, and the other thing is that we have the new all electronic toll collection, such as the Turnpike here in Florida is in the process of implementing, starting in South Florida, eliminating all cash collections, is dramatically, it's an order of magnitude less costly than cash toll collection that people were used to in the 20th century. So we've got a whole lot of reasons why it's worth looking at whether toll financing could be the way to do this. And there's also global infrastructure funds that have pools of capital ready to do projects like this. So what we did in the study is a very quantitative study using all Federal Highway Administration data, because it's sort of the best, most uniform source. We estimated the costs state by state, not just as an aggregate, but state by state from the bottom up, of reconstruction and widening of the entire system. We use the Federal Highway Administration's freight analysis framework, more detailed data, to look at their projections of truck traffic to identify the corridors for truck lanes. We used as a baseline the same uniform toll rates everywhere in the country, even though that's not realistic. They'd have to be tailored to the specific roads and so forth. But just to get a baseline idea of the feasibility, we use the same rates everywhere. But critically important, and unlike fuel taxes, we use annual CPI adjustments in projecting the revenue on the grounds that we learned a bad lesson in designing fuel taxes. They should have been CPI adjusted from the start, or some other cost index. If we're going to do a major set of mega projects, we need to use CPI adjustments to make it realistic. We also used moderate congestion pricing in the urban areas, peak versus off-peak rates, built that into the modeling. And the basic feasibility test was the net present value of revenues over the whole, I think we used a 35-year period, compared to the net present value of the cost. Now, that's not sufficient to say you can do a toll financing, but it's a basic first cut order of magnitude. Is this worth considering or not? So you'll see as we go forward that it turned out to be worth looking at. Specifically for toll revenues, we did rural rates separately from urban rates, again, because the urban areas, we wanted to use peak and off-peak pricing. We got VMT growth rates from a new methodology recently developed by the DOT's Volpe Center in Cambridge, Mass, right next to MIT. So we had, for each state, we had a estimated growth rate based largely on the growth of population, because it looks like VMT per capita, most experts are pretty convinced that's topped out. People have about reached the point of how much they're going to be driving per year. But the population is going to be growing. It's going to be growing at different rates in different states. Florida, it's going to be growing fast. Texas, Arizona, New England, not very much at all. So the rates reflect that. For truck traffic, they have separate rates for trucks. There, it's more based on the growth, the economic growth of each state. And the truck rates tended to be at least twice as fast growing as the personal vehicle rates. And that's, again, sort of the consensus among transportation economists and forecasters. The baseline rural rate, everything is based to 2010, because that's the latest data we could get. We use 3.5 cents a mile for cars and 14 cents a mile for trucks. Most toll roads charge 4 times as much for heavy trucks as for cars. And again, these are CPI adjusted. We then in the we use net revenue in the feasibility calculation rather than gross revenue. This is typically done in toll road traffic and revenue studies. You don't use the gross revenue because people who buy toll revenue bonds, which are the basic way in which toll roads are financed, they're not dumb. They know that people have a choice of using a toll road or not. And you've got to make sure that the toll road is adequately, properly maintained so that it's better, on average, better condition and better performance than the free roads. So in all the standard toll revenue studies, they build in maintenance as an initial, before even the investors get their annual bond interest payments and so forth, the revenue has to be set aside in a separate account for proper ongoing maintenance. So what this study is looking at is not only the cost of building, but also the cost of operating and maintaining the rebuilt system. So the first part was to do the reconstruction analysis, not considering lane additions, simply replace all the existing lane miles with the best modern pavement designed for minimizing life cycle costs. Results of that were very positive. Using our basic CPI-adjusted baseline toll rates, the NPV of net revenue exceeded the NPV of estimated reconstruction costs in most of the states, in fact, a large majority. But when we looked closely at the traffic that underlay those revenue numbers, in a lot of places, it looked clear that there was more traffic than the existing lane miles could handle. So the next step then was to assess the widening needs, and we did that, again, on a quantitative basis. When we did the reconstruction analysis, we were able to use the published data in the highway statistics tables that FHWA puts online, and has state-specific data, but it has for all the interstates in a given state as a unit, and that's how we did the reconstruction analysis. When it came to widening, you've got to go corridor by corridor. So we had to get from federal highways detailed data, let's say on Interstate 75 in Florida, Interstate 75 in Georgia, et cetera, et cetera. So much more number crunching, many more spreadsheets to do. And we used our VMT projections to do a daily vehicle miles of travel per lane mile, which relates directly to level of service, to look at it at 10-year intervals, 2010, 2020, 2030, and 2040, and look at where you would meet a threshold of needing widening. And we used, those of you in